Have you ever sort of peered into this digital infrastructure that powers pretty much everything we do online?
It's kind of invisible, isn't it?
Totally. I mean, from the AI that's, transforming industries to just streaming your favorite shows,
Hmm.
there's this complex, unseen world of massive data clusters working tirelessly behind the scenes.
A huge hidden world.
Exactly. The field just packed with innovation. And today, we're taking a deep dive into a really crucial part of that world, Dell PowerScale systems.
Good topic.
Now, our journey into PowerScale is going to be a bit, well, unconventional.
Oh.
Yeah, instead of a typical research paper or something, our source material for this deep dive is actually a set of exam prep questions.
Okay, interesting approach.
Right, and there are incredibly detailed explanations for the D-PSC-MN-01 certification. This exam, it covers the critical aspects of PowerScale, everything from core hardware, essential maintenance, to installation, and even advanced implementation.
That's right. And our mission here, it isn't just to, walk through answers. Yeah. We want to use these questions as a strategic jumping off point to really unpack the foundational concepts of PowerScale.
Mm-hmm.
Think of it as a potent shortcut to being genuinely well-informed about how these powerful, scalable systems actually operate out there in the real world. We're going to pull out the why it matters from each technical bit.
Yeah, connect the dots. And just to give you a clear roadmap for this deep dive, the D-PSC-MN-01 exam itself is broken down into 4 equally weighted areas. These will structure our conversation.
Makes sense.
We've got PowerScale hardware concepts, PowerScale hardware maintenance, PowerScale hardware installation, and PowerScale implementation. Okay, let's unpack this.
All right, let's do it.
So, first up, imagine you're like the conductor of an orchestra, right? But instead of musicians, you're managing a massive data cluster, petabytes of information flowing constantly. How do administrators even begin to get a handle on all that? What tools give them that bird's eye view?
Yeah, that's a great analogy. And the answer there is the OneFS Web UI dashboard. It becomes absolutely indispensable.
The dashboard, okay.
It's your real-time command center. It gives you a comprehensive overview of the entire cluster's status. So you see system health, active alerts, performance metrics, all pretty much at a glance.
So easier than digging through logs constantly.
Oh, definitely. True genius isn't just avoiding complex command line interface or CLI commands, though that's nice. It's really in democratizing system health.
Democratize. How so?
Well, it allows even less specialized personnel to kind of grasp the cluster's heartbeat.
Yeah.
Turns potential issues into maybe just mere blips on the radar before they blow up.
That instant visibility sounds, well, incredibly critical. I mean, in these high-stakes IT environments where every second of downtime costs a fortune.
Yeah.
What really stands out to you as the most significant benefit of having a dashboard like that?
Well, what's fascinating here is that it really enables proactive management.
Proactive, right?
Instead of just reacting to a full-blown crisis, you can identify these minor anomalies before they escalate.
Catching things early.
Exactly. It's the difference between making a minor adjustment and, facing a full system shutdown, which, like you said, can cost an absolute fortune in today's always-on world.
Okay, speaking of being proactive, let's talk about the physical side, the hardware. What happens when that dashboard flags a problem with a critical component? Let's say a power supply unit, a PSU, in one of the nodes. Before you even touch that hardware, what's the absolutely non-negotiable first step?
Right, good question. Before any physical replacement of a faulty PSU, you absolutely must use the IZ status command.
Easy status, okay.
Yeah.
Why that specifically?
Well, this command is your preliminary diagnostic check. It verifies the node's current health and its operational status before you do anything physical.
Ah, so you confirm it's actually the PSU.
Exactly. It's crucial because it confirms the node's condition and helps ensure you don't accidentally disrupt cluster operations or, replace hardware unnecessarily. I've actually seen situations where someone skipped this step.
Oh.
Yeah, they assumed a PSU was bad, went to replace it, only to find out later it was just a loose network cable or something, and they needlessly took down part of the cluster in the process.
Ouch. That neatly explains the why. Okay, so with a system this capable, it must be engineered for some very specific, very demanding tasks. When we talk about the most performance-intensive workloads out there, things like artificial intelligence, AI model training, heavy-duty big data analytics, which PowerScale platform is really optimized for that kind of heavy lifting.
Right. And here's where it gets really interesting for those cutting-edge applications. That would be the PowerScale F900 platform.
F900.
Yep. It's purpose-built for those incredibly demanding workloads. We're talking high CPU and GPU resources,
Yeah.
incredibly fast flash storage, and extremely low latency.
So speed is the name of the game.
Absolutely. Think of it this way. For AI models that maybe used to take weeks to train, the F900 can potentially slash that time down to days. It fundamentally accelerates innovation. It's not just fast stored. It's really a catalyst for data-driven breakthroughs.
That's a serious differentiator. Okay, now these systems, they're designed to grow, right? Expand with an organization. So when you're expanding your cluster, adding new nodes, how does PowerScale automatically handle the rather messy details of IP address assignment? Is it a manual nightmare, or is there some clever feature at play?
Hey, thankfully, it's definitely not a manual nightmare. There's a feature called Smart Connect.
Smart Connect.
Exactly. That's the intelligent feature responsible for automatically assigning IP addresses and managing load balancing for new nodes when they join the cluster during expansion.
So it just handles it?
Pretty much. This intelligence ensures the seamless integration of new hardware without needing manual network configuration. It's a huge time saver, and importantly, it significantly cuts down on the potential for human error. It's all about maintaining agility as your data footprint grows.
That's clever.
Yeah.
Now, shifting back to the physical aspect, especially in data centers, we know every single inch of rack space counts. So what is the rack unit size of a Dell PowerScale F200 node, and why does that specific size matter so much in a, constrained data center environment?
Okay, yeah, the physical space is key. The Dell PowerScale F200 node, it's designed to fit into a single rack unit, just one U.
On you, pretty small.
Right. And this compact form factor is absolutely vital. It allows data centers to maximize their compute and storage density, often within pretty limited rack space.
So more power in less space.
Essentially, yes. You can fit more processing and storage power into a smaller physical footprint. This directly optimizes efficiency and helps reduce operational costs for our clients. Honestly, anyone who's ever tried to squeeze just one more server into a packed rack knows that one U can make all the difference.
I can imagine. Okay, so even with the best design systems, problems inevitably pop up sometimes. If you're facing an issue in your cluster and you need to get to the root cause, maybe for Dell support, what's the main tool you'd use to collect all that crucial diagnostic information?
Right. When you need to dig deep and figure out what's wrong, the IC Diagnostics Gather command is your main go-to tool.
It's Diagnostics Gather. Got it.
Its primary purpose is to collect really comprehensive diagnostic data and logs from all the nodes in the cluster. It gives you a complete picture.
The whole story.
Exactly. This collected data package, this bundle of logs and info, is essential for Dell support teams to analyze issues accurately and provide effective troubleshooting. It's kind of like sending them a complete medical history of your cluster, helps them pinpoint the exact ailment much more quickly.
Makes sense. Okay, switching gears a bit to network access. For network file system clients, NFS clients, to successfully mount shares from the cluster, what specific configuration must be in place on the PowerScale side? What's the sort of gatekeeper there?
Yeah, security and access. This raises an important question. For NFS clients to mount shares successfully, host-based access permissions are crucial. Absolutely crucial.
Host-based permissions.
Yes. The cluster has to be explicitly configured to allow access based on the client's host name or maybe its IP address. This system secures the data access and, critically, prevents any unauthorized mounts from happening. It's really a fundamental security practice.
So without it,
Your data would essentially be like an open door to anyone on that network segment. Not good.
Definitely not good. Okay, that leads us to maybe a more puzzling scenario. What exactly happens when a node in your cluster starts displaying a red LED status, clearly indicating a problem, but strangely, it actually remains online? It seems to still be operating within the cluster. Is it like a ghost in the machine, or is this something PowerScale designed for?
No ghosts. It's definitely by design. It's actually quite clever.
Okay.
When a node's LED indicator turns red, but the node itself stays online, OneFS, that's the operating system, initiates an intelligent quarantine mechanism.
Quarantine, like it isolates it.
Exactly. It effectively isolates or quarantines that specific node to protect the overall integrity of the entire cluster.
So it walls it off.
Precisely. This action is critical because it prevents the faulty node from affecting data availability or, worse, causing broader problems across the rest of the cluster. It maintains stability and protects your valuable data from potential corruption or loss caused by that one iffy node.
That's smart. Okay, nearly there. Before you even physically install any new hardware into a PowerScale chassis, like before you plug in any cables, what's a non-negotiable safety step? Something that absolutely must be taken first.
Okay, safely first. Always. The critical, absolutely non-negotiable safety step before physically installing a node is verifying proper rack grounding.
Grounding.
Yeah.
Seems basic but important.
Paramount. Grounding protects both the expensive hardware and the personnel working on it. It prevents electrical faults, static discharge, which can fry components instantly, and potential damage or injury during the installation process. It really is the first line of defense for electrical safety, and honestly, sometimes overlooked in the rush to get new gear online.
Don't skip the grounding.
Ah.
Got it. Finally, let's talk about one of the most impressive feats, I think, in enterprise IT. How do PowerScale clusters manage to update their core software 1FS without causing any service disruption? Because, let's face it, taking down a massive data cluster is usually just not an option for any business today.
Yeah, zero downtime is the goal. So what does this all mean for continuous operations? It means the rolling upgrade feature is an absolute game changer.
Rolling upgrade.
That's the one. This feature allows cluster administrators to update the 1FS software on the nodes one at a time, sequentially.
One by one?
Exactly, without needing to take the entire cluster offline. This approach is absolutely key to maintaining continuous availability and service during the upgrade process. It's crucial for any business relying on constant data access. It truly sets PowerScale apart from older systems or even some current ones that still require scheduled downtime windows for updates.
Wow. And there you have it.
Think about how these seemingly granular details, these little commands and features, actually underpin the reliability of services you interact with every single day.
Yeah.
Cloud storage, streaming video, online banking, often without you even realizing what's making it all work so seamlessly.
It really is amazing how understanding these underlying systems can provide such valuable insight into technology. Even if you aren't working directly with PowerScale yourself, you definitely start to see the digital world in a whole new light. Thanks for joining us on this deep dive.